Europe is about to split straight down the middle, one side baking under a heat dome pushing back toward 45 degrees, the other side finally catching a break with storms and cooler air. And the line between those two very different weeks is shifting fast. Stick with me for the next few minutes, because I'll walk you through exactly where you land on that divide. And hit subscribe now, because I break down what's actually happening with the weather, not just what's scary in a headline. Let's start with the big picture, because 2026 has already been an extraordinary year for heat across Europe. And understanding that background is exactly why this next stretch matters so much. This summer has already produced multiple separate heat waves, stacking one on top of another. The first arrived unusually early, back in late May, smashing records in Belgium and setting the tone for what was coming. The second hit in June, driven by what meteorologists call an omega block, a stubborn high-pressure system shaped like the Greek letter it's named after, which parked itself over Western Europe and simply refused to move, setting temperatures past 44 degrees Celsius in places and pushing well into Central and Eastern Europe as the block gradually shifted. That June heatwave broke all-time June records in the UK, France, the Benelux countries, Germany and Switzerland. And it came with a genuinely serious human cost, with hundreds of heat-related deaths reported across the continent as the extreme temperatures moved eastward. To put some specific numbers on just how extreme that June event actually got, Barcelona recorded its hottest temperature in over a century. Germany breached 40 degrees Celsius with peaks close to 41, hot enough in places that some autobahns reportedly buckled under the heat. And the United Kingdom broke its own record for the most days in a single year above 34 degrees Celsius, all while sitting under an amber extreme heat alert covering almost the entire country. National weather services across Germany, Poland, and the Czech Republic issued red alerts for extreme wildfire danger during that stretch, since the combination of very low humidity, high winds, and extreme heat created exactly the conditions needed for fires to spread quickly and unpredictably. That is the backdrop this current pattern is building on top of, not a fresh, cool start to summer, but ground and infrastructure already strained by two previous extreme heat events in the space of about 6 weeks. Now we're watching a third distinct heat event build, and this time the pattern is doing something specifically important, splitting the continent into two very different experiences depending on where you happen to live. Here's the actual mechanism driving that split, and it's worth understanding properly rather than just accepting it as a vague forecast claim. The jet stream, the fast-moving river of air high above our heads that steers most of Europe's weather, is lifting up toward Iceland and Norway, which is a fairly typical summer pattern on its own. But behind that lift, there's a sharp dip, a trough, dropping down into Central and Northern Europe. And that dip is what's opening a corridor for cooler air off the North Atlantic to push into the middle and eastern parts of the continent. At the same time, a strong ridge of high pressure is holding firm over Western and Southwestern Europe, and that ridge keeps pulling in hot air originating from North Africa. Put those two features together, and you get exactly the divided pattern meteorologists have been tracking cooling and storms working their way through Central and Eastern Europe, while the West and Southwest stay locked under building heat, or in some cases, watch that heat intensify even further. It helps to understand why forecasters place so much weight on this particular jet stream shape when making these predictions. When the jet stream runs in a relatively flat, straight line across the continent, weather tends to move through quickly, and no single region gets stuck under the same conditions for too long. But when it buckles into a large ridge and trough pattern like the one currently in place, why, with a lifted ridge in one location and a drop trough nearby, weather systems essentially get trapped, holding their position for days or even weeks at a time, rather than sliding through and moving on. That is exactly the mechanism behind the earlier omega block that drove June's record heat, and it is the same broad category of pattern responsible for this current split, just reshaped into a configuration that divides the continent rather than parking heat over one single region. If a clear explanation like that is what you actually want from a weather channel instead of just scary maps with no context, go ahead and drop a like on this video, because it genuinely helps this kind of coverage reach more people. Let's talk about the western side of this split first, because that's where the most intense heat is building right back up. Iberia and France are moving back into a hot, dry, high-pressure regime, and forecasters are watching temperatures climb toward the low to mid-40s Celsius across Spain and Portugal, with similar extreme readings possible across central, western, and southwestern France. That kind of heat is enough to challenge regional July records in some areas, and it's arriving on top of ground that's already exceptionally dry from the earlier waves this summer, which means the heat compounds an already serious drought situation rather than starting from a clean slate. Southern England is also likely to get pulled back into the same hot, dry pattern as the week develops, following the same track that brought record-breaking heat to the UK earlier this summer. It is worth understanding exactly why dry ground makes a heat wave like this worse rather than simply hotter. When soil holds a reasonable amount of moisture, some of the sun's energy hitting the ground gets used up evaporating that moisture, rather than directly heating the air above it. A natural cooling effect, similar to how sweat cools your own skin. Once soil dries out completely after weeks of limited rainfall, that natural buffer disappears, and nearly all of the sun's energy goes directly into heating the air instead. Which is part of why a heat wave arriving on top of an already dry summer tends to feel more intense and produce higher peak temperatures than the exact same weather pattern would if it arrived after a wetter spring. That is exactly the situation much of Iberia, France, and southern England are facing heading into this next round of heat, since the ground beneath them has had very little chance to recover moisture since the earlier waves back in May and June. Now here's the eastern and central side of the story, and this is genuinely the more comfortable half of the split, at least temporarily. Central Europe and parts of Eastern Europe are getting a real, if temporary, break from the worst of the heat, with cooler air pushing in from the northwest, and a series of thunderstorms moving through as that front works its way across the continent. This is exactly the kind of pattern where you'll see storms firing up near the Alps and across northern Italy first, then shifting toward southeastern Europe over the following days as the front continues sliding east. Some of these storms carry real teeth. Where the atmosphere is most unstable, expect the possibility of severe weather, meaning damaging downburst winds capable of causing wind damage, large hail in some spots, and in the more intense pockets, even an isolated tornado can't be ruled out. Areas from Switzerland, Austria, and Slovenia down through Croatia and Bosnia are in the front line for the first wave, with Poland, Czechia, Slovakia, and Hungary picking up showers and storms shortly after, and the activity continuing to slide toward Romania, Ukraine, Serbia, Greece, Bulgaria, and North Macedonia as the pattern progresses through the following days. It's worth explaining briefly why this particular type of storm tends to turn severe so reliably during a pattern like this one, when a pocket of relatively cool, dense air pushes in at the leading edge of a front, and it runs into air that has been baking under days of intense heat and humidity built up ahead of it. That sharp contrast creates enormous instability in the atmosphere. Warm, moist air near the ground gets forced rapidly upward once the cooler air wedges underneath it. And that rapid upward motion is exactly what fuels the tall, powerful thunderstorm clouds, capable of producing large hail, sudden destructive wind gusts, and, in the most extreme cases, brief tornadoes. The bigger the temperature and humidity contrast between the two air masses colliding, the more violent the resulting storms tend to be, which is part of why forecasters are specifically flagging severe weather potential along this particular boundary, rather than expecting only ordinary rain showers. It's worth being honest about what these storms will and won't actually accomplish, because it's a detail that gets lost in a lot of weather coverage. These downpours don't do a whole lot for the underlying drought conditions in most of the affected areas. You get a quick, heavy burst of rain that runs off fast, rather than soaking deeply into ground that's already baked hard from weeks of heat. So you end up with a real risk of flash flooding in low-lying areas, even while the broader drought barely improves. What the rain does add is humidity and moisture into the atmosphere, which can actually make the air feel more uncomfortable afterward, rather than delivering the clean, dry, refreshing cool down people might be hoping for. So if you're in one of these storm target zones, the message is straightforward. Watch for lightning, watch for sudden localized flooding, but don't expect this rain to meaningfully fix the dry conditions that have been building across much of the continent all summer. It helps to understand exactly why heavily baked, drought-stressed soil behaves so differently from normal ground when a burst of heavy rain finally arrives. Soil that has been dried out for weeks develops a hardened, almost crust-like surface layer, especially in areas with a lot of clay content, and that hardened surface actually repels water rather than absorbing it. In much the same way water beads up and runs off a dry sponge before eventually soaking in properly. When a thunderstorm dumps a large amount of rain in a short burst onto ground in that condition, most of the water simply runs across the surface rather than sinking down to recharge the deeper soil moisture that crops, rivers, and reservoirs actually depend on. That is exactly the mechanism behind the frustrating pattern where a region can experience a genuinely dramatic, damaging thunderstorm complete with flash flooding and still be facing serious ongoing drought conditions the very next week, since the two outcomes, surface flooding and deep soil drought, are not actually contradictory once you understand how dried out ground responds to sudden heavy rainfall. If you're the kind of person who wants the honest version of a forecast instead of just the dramatic parts, drop a comment and let me know where you're watching from, because it genuinely helps me understand how far this coverage is actually reaching across the continent. Let's talk specifically about the north for a moment, because Scandinavia and the Baltic states are sitting in a genuinely interesting spot within this whole pattern. Norway, Sweden, Finland, and the Baltic states have generally been running cooler than areas further south and west this stretch, with daytime readings mostly sitting in the high teens to low 20s Celsius, rather than the extreme readings further south. But there's a specific detail worth flagging for Finland, and the Baltic states in particular, because the rainfall totals building up there over the coming days are genuinely significant. Some areas could see accumulated 5-day rainfall totals reaching well over 100 millimeters, with isolated spots potentially approaching 150 millimeters. That is a serious amount of rain concentrated in a short window, and it raises real flash flooding potential in those specific areas, even though the broader story for that part of Europe is one of relatively comfortable below-average temperatures rather than heat. It is worth understanding why this particular region ends up catching such a concentrated dose of rain while sitting relatively comfortably on temperature. As that storm track lifts up toward Iceland and Norway, it effectively channels a repeating stream of weather systems along roughly the same path, one disturbance after another, each one riding along the same general corridor rather than spreading out and weakening across a wider area. When that kind of repeated, closely spaced train of systems tracks over the same general region, in this case Finland and the Baltic states, the rainfall from each individual system adds directly on top of the last one, which is exactly how a place with generally comfortable, moderate temperatures can still end up facing genuinely serious flash flood risk purely from the sheer volume of repeated rainfall stacking up day after day. Meanwhile, the Netherlands and Belgium are looking mostly dry through this stretch, and areas further west, including Wales and Ireland, will see some rain moving through as a weak weather disturbance passes by, bringing a modest secondary round of showers that could add up to a meaningful amount of rain in some spots, without the same severe storm risk found further south and east. Here's the part of this forecast that really matters if you're trying to plan more than a couple of days ahead, because the pattern doesn't stay static. As the week progresses, that western ridge of high pressure is expected to build in even further, meaning the heat over Iberia, France, and the near continent doesn't just hold steady. It's forecast to intensify. By the later part of the week, some areas working back toward Spain in particular could be looking at daytime highs pushing up toward 40 degrees Celsius, and Paris sits right on the edge of what would be classified as significant heat by that point too. Meanwhile, over toward the eastern half of the continent, temperatures generally continue trending in the opposite direction, staying below average, or dropping further as that cooler, stormier pattern holds its ground longer in places like Ukraine and the surrounding region. That divide between a strengthening western heat dome and a persistently cooler, wetter eastern half of the continent is really the whole story of this coming week, compressed into one sentence. It's worth understanding why this kind of seesawing pattern, hot one week, a partial break the next, then heat building right back up again, has become such a recognizable feature of recent European summers rather than a one-off event. This year alone has already produced 3 distinct heatwave events layered across May, June, and now July, each one separated by only brief periods of relief rather than a genuine extended cool down. Meteorologists tracking this pattern describe it as a hallmark of a warming climate, where the atmospheric blocking patterns responsible for trapping heat in place are becoming both more frequent and more stubborn, holding position for longer stretches before finally breaking down and shifting elsewhere. That doesn't mean every summer will look identical going forward, but it does mean that a pattern like the one we're watching right now, intense heat building, briefly retreating, then rebuilding somewhere else on the map, is worth understanding as part of a broader, ongoing shift, rather than dismissing it as an unusual, isolated week. It also helps to understand why a blocking pattern like this specifically tends to produce a divided continent, rather than uniform heat or uniform cooling everywhere at once. A traditional heat wave without any blocking involved tends to move through relatively quickly, arriving, peaking, and then clearing out within roughly a week, as normal weather systems continue their usual eastward progression. A blocking pattern disrupts that natural progression entirely, essentially forcing weather systems to detour around a stubborn zone of high pressure rather than moving straight through it. That detouring is exactly what creates a sharp boundary between two very different weather experiences sitting relatively close together geographically, one side trapped under the block itself, the other side catching whatever weather gets diverted and funneled around its edges. Understanding that mechanism is really the key to understanding why two cities only a few hundred kilometers apart can be experiencing such dramatically different weather at the exact same moment during a pattern like this one. There's also a genuine health dimension to this story that deserves more attention than it usually gets, particularly for the areas about to move back into the hottest part of this pattern. One of the more dangerous aspects of a prolonged heat pattern like this involves what are called tropical nights, meaning nights where the temperature never actually drops below 20 degrees Celsius. During an extended heat wave, especially in cities where concrete and asphalt hold onto daytime heat well into the night, those warm nights prevent the human body from properly recovering from a hot day before the next one begins. If overnight lows stay above roughly 25 degrees in some of the more intense urban heat pockets, people effectively start the next day already under heat stress, with no real overnight break to reset. That layering effect, heat that never fully lets go even after the sun goes down, is a big part of why extended heat waves become more dangerous the longer they persist, rather than the danger simply staying constant from one hot day to the next. This is exactly why health authorities across the region most likely to be affected by this next round of heat, Spain, Portugal, France, and southern England, tend to issue their strongest warnings not necessarily on the single hottest afternoon of a heat wave, but several days into a sustained stretch, once that lack of overnight recovery has had time to build up across a population. The people most at risk in this kind of pattern are consistently the same groups: older adults, particularly those living alone without reliable air conditioning, infants and young children, outdoor workers who cannot avoid midday heat exposure, and anyone already managing a heart or respiratory condition. Simple precautions genuinely help here: staying hydrated throughout the day rather than only when feeling thirsty, avoiding strenuous outdoor activity during the hottest hours of early afternoon, keeping living spaces as cool as possible during the day by closing blinds and curtains and checking in directly on older relatives or neighbors who might be less likely to adjust their own routine around the heat on their own. There's also a less obvious consequence of this kind of sustained heat worth understanding, involving something most people never think about at all: how power plants actually cool themselves down. Nuclear power plants across parts of Europe rely on river water for cooling their systems. And when that river water is already running unusually warm because of a prolonged heat wave, returning even warmer water back into the river afterward can genuinely damage the surrounding aquatic ecosystem. Environmental regulations in several countries are specifically designed to prevent that kind of ecological harm, which means plants can be forced to reduce their output precisely during the moments when electricity demand for air conditioning and cooling is at its absolute highest. It's a genuinely awkward collision between environmental protection rules and immediate energy demand. And it's exactly the kind of secondary effect that rarely makes it into a typical weather forecast, even though it can directly affect the electricity grid people are relying on to stay cool in the first place. This same dynamic played out visibly during the earlier heat waves this summer, with several plants across France in particular required to reduce output during the hottest stretches of June, precisely the period when national electricity demand for cooling was climbing toward its seasonal peak. Grid operators generally plan around this kind of predictable tension by importing additional power from neighboring countries, or drawing more heavily on other generation sources during the hottest days. But it does mean that a genuinely severe, sustained heat wave carries knock-on effects for energy supply and pricing that extend well beyond the immediate discomfort of the heat itself. It's one more example of how a weather pattern like this one ripples outward into systems most people never directly associate with the forecast at all. So here's how to actually use all of this depending on where you are. If you're in Spain, Portugal, France, or southern England, the trend over the coming days is unmistakably upward, building towards some genuinely serious heat by the latter part of the week, on top of ground that's already dried out from earlier in the summer. So this is exactly the kind of stretch where you want to be planning around the hottest part of the afternoon, staying hydrated and checking in on anyone in your life who might be more vulnerable to extended heat. If you're across Central Europe, from the Alps through Poland, Czechia, Austria, Slovakia, and Hungary, expect a genuine, if temporary, break from the worst heat, but stay alert for thunderstorms carrying real potential for damaging wind gusts, large hail, and localized flash flooding, particularly during the first half of the week before the activity shifts further east. If you're in southeastern Europe, from Romania and Ukraine down through Serbia, Bulgaria, Greece, and North Macedonia, that same storm risk arrives a little later in the sequence. So keep an eye on the back half of the week specifically. And if you're up in Scandinavia or the Baltic states, temperatures stay comfortably below the extremes further south, but watch closely for the genuinely heavy rainfall totals building up, especially across Finland and the Baltic region, since that's where the flash flooding risk is actually concentrated in the northern half of the continent. It's also worth remembering that a pattern like this one rarely resolves itself in a single clean, tidy way. Blocking patterns of the type currently shaping this divide have a tendency to wobble before they fully break down, meaning a region currently expecting relief could see a brief return of heat before conditions genuinely improve, and a region currently baking under the ridge could see the first signs of a real change, arrive a day or two earlier or later than initially expected. That kind of uncertainty is normal for a pattern this large and this persistent, and it's exactly why staying updated across the week matters more than fixating on a single number from a forecast issued several days in advance. None of this is the kind of story with a single dramatic ending. It's a genuinely fluid pattern, and the exact line between the hot side and the cooler, stormier side of the continent can shift by a day or two in either direction as new data comes in, which is exactly why it's worth checking back for updates rather than locking in a single forecast from several days out and assuming it holds perfectly. If you want the accurate, updated version of this story as the pattern continues developing through the week, subscribe to this channel and turn on notifications, because I'll keep tracking exactly where that heat and storm divide ends up landing. And I'd rather you get that update here than piece it together from scattered headlines somewhere else. Stay safe out there, whichever side of the split you happen to be on this week, and have a good one.